Okay, the next step in terms of inequalities is what we call compound inequalities. So what I've done is I pulled the definition for compound out of the dictionary, and I've highlighted a couple of pieces here. One, when you get to compound in the green, it says consisting of two or more substances, ingredients, elements, or parts. In the yellow, we talk about is composed of more than one part. So what we're really talking about when we say compound inequalities is we're talking about more than one inequality. Now we're going to simply see two at a time for the most part here. Down the road, if we get into some linear programming, we see multiple inequalities. But right now we'll be concentrating on, two. Okay, so we'll have to deal with two things happening. And you've seen these before in the idea of the or and the idea of the and. Okay. So now what we can talk about is, this is a common example I'll use and have students stand up and say, okay, stand up if you're a junior or a female. So Lisa could stand up because she's a female. Jeff can stand up because he's a junior. Sandy can stand up because she's a junior. She can stand up also as a female. Now, when I go into the idea of junior and female, now I can only deal with Sandy and Lisa, okay? Because they have to satisfy both conditions. You can't be one or the other. You have to be both. So that's one of the things that happens with an or. We have to satisfy at least one of the conditions. Okay, so because Lisa satisfied the condition of being a a female, she was able to stand up. Because Jeff was a junior, he was able to stand up. Because Sandy satisfied both junior and female, she satisfied at least one, she was able to stand up. But when we get to the and, you have to satisfy all conditions. And I don't just say two here or both because of the fact that it can be more than two. Okay, so we have to satisfy all the conditions. Not only do you have to be a junior, but at the same time, you also have to be a female. Now, I'll generally start in our compound inequalities with the or situation, because one of the things with an or situation, the word or will always be included. If I don't see the word or, there's no way it can be an or situation. It has to have the word or in it. Okay, and what you'll see is that I have two separate situations here. Okay, I have the inequality that says that I need 3x minus 1 to be less than negative 1. So I'm looking for x's that satisfy that inequality. Or I'll take x's that satisfy this other inequality, 2x plus 5 greater than or equal to 11. The nice thing about ORs is they're pretty straightforward because all I'm going to do is solve each one of these individually. So if I solve this first one, I'm going to go in, add 1 to both sides to get that to go to 0. Left side, or right side, also goes to 0. Do my division by 3 to multiply that to 1, so x's are less than or equal to 0. Okay, so any x's that are less than or equal to 0 right now are part of my solution set because of the fact they satisfy one of my conditions. Okay, so now I go in and I solve my second one. Get my 5's to go to 0. Okay, divide by 2 to make that go to 1. And so any x's greater than or equal to 3 now are also in my solution set. So if I pick any numbers that are either less than or equal to 0 or greater than or equal to 3, I'm in great shape. Okay, those are what I want. Those are successes. Okay, so if I pick negative 4, hey, that's less than 0. We're good. If I pick 10, that's greater than 3. That's good. If I pick 1, 1 will not be in my solution set because of the fact that it's not less than 0 and it's not greater than 3. So a couple things that will happen here now. We're going to ask for two things when we talk about our solution to a compound inequality. One, we're going to want our algebraic solution. All we talk about with an algebraic solution is, okay, what's my solution in terms of x? Very easy. Throw that word or back in there because, again, anytime we talk about ors, we're going to see the word or. So algebraically, my solution is any x's that are less than or equal to 0 or any x's greater than or equal to 3. Okay. The other piece that we want to do is see it graphically. Because with inequalities, again, remember we talk about an infinite number of solutions in general. Okay, and so what we want to see is where are those numbers on the number line that work for these inequalities. So pretty simple as well. Here's my number line, and what I want to do is graph both of my inequalities. So I'm going to start with the x less than or equal to 0. So again, you put your number on the number line, equal sign, so we close it up. X less than, points left, so we're going that way. Put your other point on there, 3. Make sure they're in the correct order. I've seen too many times students just put the first number they found on the left, then the second number on the right. Make sure we go left to right in terms of least to greatest. So 3, we got the equals, pointing right, greater than is there. Okay. Now, one of the other things I like to do then is, and you'll see this more with the and, is then scribble where my solution actually is. So because it's or, anywhere I have an arrow is a solution. So there's my final solution set. And in general, ors, the graph will look like this, where you have your 2 points and they go away from the middle. Okay, in general. There are situations where that doesn't happen, but as I'm solving a situation, I graph my or, and if they cross, then I'm going to go back and double check to make sure I'm doing things correctly. All right, now with the and situation, one of the things that's a little different, we don't see the word and. But I'm going to turn it into a situation similar to the ors. I'm going to do, like it says here, I'm going to break it into individual inequalities and then solve each one. What your solution set in the back of the book when you get answers will look like, it'll say something like this. Okay. And when we read that, we say -4 less than x less than 7. Okay, so visually, sometimes we can see that, hey, what they're talking about is I need some numbers between -4 and 7. Okay. But now when we read it again, we get into trouble. I need -4 less than x. And again, talked about this, how your brain hears less than and that number -4, so it thinks its number smaller. I got to turn that around. Okay. I want x's that are greater than -4. This part, x is less than 7. And what I'm going to do is I'm going to throw that word and in between them to make it simpler for us, make it more like the or situation. So what I'm looking for are x's that are less than, or greater than, than -4, and at the same time, x's that are less than 7. So that again, if you think about our numbers between -4 and 7. So the big piece you got to be careful of here is this 2x plus 7 is similar to this x. That's your middle piece. Because what we're going to talk about is I'm going to compare my first piece with my second piece. That's going to be one of my inequalities. So my first piece, -1, is less than my second piece. It's that whole chunk, 2x plus 7. Okay. Then I'm going to look at the second piece, the x, has to be less than 7. So here, the second piece, the 2x plus 7, is going to be less than the third piece, the 19. And then I'm going to throw that and in between there. Now it's just like an or. Now I go in and solve just like I did those other ones. Okay, so subtracting the 7 from both sides, dividing both sides by 2. And again, one of the things I want to do in this case is turn it around so my x comes first. Okay, so we did that with all our just singular inequalities, so we're going to do that again with our compounds. We want to put my x's on the left, so then I go to work on solving this one, and I get my x is less than 6. Okay. So now we need to again write it algebraically. And to keep it simple, I tell people just go ahead and write it like this. Throw that and in between there. Now, the problem that'll happen is people will get confused because now my answer in the back of the book is going to take on that type of a form. Okay. I can rewrite it in that form real easily after I graph. Okay. After I graph, it's very easy to write it into that compound single form without the word and in there. So if I come in here and graph these, okay, the first one, -4, okay, no equals, so it's open, greater than, pointing to the right. 6, no equals, so open, pointing left. Okay. Now, here's where the scribble part comes in. Remember, and you have to satisfy both conditions. Out here, I'm only satisfying the inequality that says x is less than 6. Okay. Out here, I'm only satisfying the condition that x's are greater than -4. Here's where I'm satisfying both of them. So I want to scribble in between because now I can see that solution set. Now, here's how I'm saying with the algebraically, makes it easier if I want to put it in one statement. Put your variable in between the two, because that's what we're looking for. We're looking for some number that's in between the two. And the numbers to the left are always the smaller ones, so that's why everything is pointing to the left. Okay. If I'm going to write it in this form, okay, I want my inequalities pointing the same direction. In general, we always point to the smaller end because we go smallest to biggest. Okay, so that's something to keep in track or keep in mind. Okay, this form is just fine. Okay, that form is just fine. Now, going with that compound piece, this is something that we do not do. We never write -2 is less than x and x is greater than 6. Because think about it. Can you have any x's that are greater than -2 and greater than 6? Yes. Okay, if I actually graph those, here's -2 greater than that. Here's 6 greater than that. What it is, it's just this part right here. Okay. But the problem is, again, is that we don't have notation like that. We want these inequalities, again, to point the same direction. This is a common error that people do when they run into the ors. They try and take the ors and run them into one single statement. Again, ors, you have to see the word or. All right, good luck with this.